Hey everyone, we're going to be talking about a brand new concept today, and that is systems of equations. In systems of equations, we're trying to find a solution that satisfies both equations. Okay, so we are leveling up and we are now dealing with two equations and two variables. Okay, something that you're more familiar with is solve for x, where we had one equation and we solved for x. We had one solution. And I'm gonna come back to check, but this is what we're used to, right? One equation, one solution. Now we are dealing with two equations, and we actually have two variables within those equations, and we need to find a solution, an x and a y, that satisfies both of these equations, a solution for this equation and for that one with both of our variables, x and y. The way we're going to do this is we are going to plug in different values and we're going to see if they work. So right now we're dealing with 0, 1 or 2, 4. We're going to test out to see if any of these solutions work for this systems of equations. We're going to do it in the same way, bringing back to our example, right? We figured out that x equals 12 here. So what I can do is I can plug that 12 back in for x in our original equation, plug in 12 for x, multiply 2 times 12, get 24, and make sure that my equation is true. Does 24 plus 5 equal 29? Yes, it does. So I can be totally certain that this is the solution for this equation. And that is the same thing that we're going to do when we're checking systems of equation solutions, but just leveling up because we have to do it 2 times and we have to use 2 variables. So let's see how this is going to work. We're going to start with this solution here. We're not sure if it's going to work, but we're going to test it out. We're going to test it out by plugging it in to one of these equations. So I'm going to take this first equation, y equals x plus 2. And remember that this is our x term and this is our y term, x comma y. So in place of y, I'm going to plug in 1, because that's what we have here, equals, what's our x? In this case, it's 0, and then plus 2. Let's fill this in a little nicer. Cool. Here's our first opportunity to check if this is a solution. Is 0 plus 2 1? No, it is not. So this right off the bat is not a solution to this equation. And if that's the case, it's not a solution to the whole system. So that one is out. Let's try that. Let's try it with this solution. And we're going to plug it into 1 or 2 and see if we get something that rings true. So I'm going to start with that first equation again. Y equals x plus 2. I'm going to go ahead and label x and y so that I plug them in properly. In place of y, I'm going to plug in 4. And that's going to equal, in place of x, I'm going to plug in 2. And then that plus 2 is going to come along for the ride. Is 4 equal to 2 plus 2? Yes, it is. So we're off to the right track here, that this is a potential solution to the system. But the thing is, it has to work for both equations, not just one. It worked for this one. Let's see if it works for this one. If it does, then we have a solution. So I'm going to rewrite the second equation, y equals 3x minus 2. And again, we're going to plug in 2, 4 for our x and y. So in place of y, it's going to be 4 equals 3. In place of x, I'm going to plug in 2. And remember, that's multiplication because it's saying 3 times x. So we're going to do 3 times 2 and then minus the 2. There's our equation with our values plugged in. Let's clean this up. Sometimes we have to do an extra step. And let's do this multiplication. 3 times 2 is 6. 4 equals 6 minus 2. 6 minus 2 is equal to 4. So we just checked if this is a solution. So we plugged this value into both of these equations and it worked. So we know for sure that this is a solution to our systems of equations. And that's where we're going to start. Thanks for watching.